Okay, related rates again. So here this problem has that a light is hung 15 feet above the horizontal path. So in this case here, here's a light. This is the 15 feet. If a man 6 feet tall is walking away, so here's a man, he's 6 feet tall, he's walking away from the light at the rate of 5 feet per second. So rate, that means it's a derivative. We need to figure out which one it belongs to here. And at what rate is the tip of the shadow moving? So here, this is the tip of the shadow right there. So we want to know how far and what rate it's actually moving. So what do? Let's fill out some information. If you notice, there's a green triangle, which is the big triangle there that contains the 15 feet. And then the man makes its own triangle. And that one's the red one. And that is as tall as 6 feet. So we are going to, because we have the vertical distance that looks like this, we need to discuss how the horizontal distance is working on there. And so we have these triangles are similar triangles because they're both right triangles and they have the same end on here. So we know that this one here is similar to the definition of similar triangles in geometry on here. So it's angle. So here, if I have these two triangles here, I'm going to break it down. And so I know that the whole distance here, the whole entire distance of the green, I am going to call that the whole distance right here. I'm going to call that X. And then I need to break this apart here. And so I need to break up the distance that he's walking away at. And so I am going to call that Y. And then the distance here, if the whole thing is X and this part there is Y, I know that this distance from here to here is going to be X, the whole thing, minus this part Y. And so that's what we have there. So now we could write down a proportion on here, but we could also figure out what the rate of so at us walking away at the rate of 5 feet per second. So that means that that's this distance right here. So that means that we have that oops, dy dt is equal to 5 feet per second. So that's that distance right there. Okay, so now we're going to set up a proportion. And the proportion that we're going to set up is the whole entire thing towards the triangle of the man. Okay, so we're going to set up a proportion. And so let's see. Okay, so equal. So, okay. Okay, so now we're going to put this in there and we're going to do the distance that we're looking for there. And so it's going to be that we have x, y, and that corresponds to the whole x. So this distance corresponds to the whole distance, so that's going to be 2x. And then this one here has to come from the same thing, so we are going to do that is 6 as this one here is 15. And so that's what we have there. These are coming from the same triangle. These are coming from the same triangle. And if I have a proportion, a fraction equal to a fraction, that's when I could do the cross multiplication. So that's the next thing we're going to do is multiply these across and do the cross multiplication. So we have 15x minus 15x minus y equals to 6x. And then we are going to solve it a little bit, make it easier to manipulate on there. And so we end up with 15x minus 15y minus 6x equals to 0. And then we combine these here and we end up with 9x minus 15y equals to 0. And so now we have a more simpler problem that we could take the derivative of it because we want to know the tip of the shadow, how fast it's moving. So we need to know what are we actually looking for. Oops, I don't know how that happened. What we're actually looking for is your dx dt because we want to know this part right here, the end of the x. Okay, so we're taking the derivative of this, and so now we're going to take the 9 is a coefficient, so we get 9 dx dt. Because we're leaving the 9 alone, we're taking the derivative of the x. We're leaving the 15 alone, it's a coefficient, taking the derivative of the y. dy dt is equal to 0. And then we say dx dt minus 15. And I know dy dt is actually 5 feet per second. And so when we solve that and we get that by itself, we are going to get dx dt is equal to approximately, well, it's equal to 75 over 9, which is approximately 8.3 feet per second. So we find our sentence, the tip of the shadow is moving at the rate of 8.33 feet per second. And that is your answer. Okay, very good. Let's do another one. A cone, similar to the ones that you guys have been doing before. So a cone-shaped coffee filter of a radius of 6. So here's 6 centimeters, and the depth 10 centimeters contains water, which drips out through a hole at the bottom of the at a constant rate of 1.5 centimeters cubed per minute. So this here tells us some information right here. And so it's cubed and it's a rate. So that's telling us about dV dt is 1.5 centimeters cubed per second. So we know that information. And so if the filter starts out full, how long does it take to empty? So in this case here, notice how it's not asking at what rate it's falling or anything like that. It's just how long. It's just asking for time. So we really don't need to find the derivative on there. We could just do some calculations on there. And so we know that this here is the volume of a cone. And so what you do here is you are just going to fill out the information. So we know that it's going to be V 1/3. I'm just going to do that in blue. So this is V 1/3 pi. And so we know that it's going to be 6 centimeters. So we have a 6. Okay, so we start here and we're going to start with V. And so we know that this here is going to be pi over 3. R is the radius, so it's 6 centimeters squared. And then times the H, which we said it was 10 centimeters squared. And so I'm not squared, just that. And so once you calculate it, you end up with V is equal to 120 pi centimeters cubed, which makes sense because the centimeters and the centimeters, and so you get a distance there. And so now it's emptying at the rate. They're already telling us the rate. So in order for us to do that, we take the 120 pi centimeters cubed, and we're going to divide it by its rate. So we could see and answer how long it's going to take there. And so we're going to centimeters cubed per second. We want the centimeters to go away because we were talking about time right here. So we just want to know how many seconds that is. So the way that happens is that we have 20 centimeters cubed, and that's over 1. And this here is over 1. And so then it's the reciprocal. And if you really want to think about it, is that this here is being divided by 1.5 centimeters cubed per second. And then you have to multiply it 120 pi centimeters cubed, and then times 1 second over 1.5 centimeters cubed. That cancels, and now you're just left with seconds. So here, we have, once you calculate it, that you get 80 pi seconds, and that is going to be approximately 251 seconds if you multiply that out. And so the answer here, the filter takes about 251 seconds to empty. So that's where you would write your sentence on there. Okay. And then it's the same problem. We're still talking about the same thing. It says find the volume of the water in the filter when the depth is, the water is H centimeters. So if I look at this, this is the proportion, and here is your H on there. And so we want to actually solve for that. And so what happens there is that it's going to be H is to R. And so we want to have this one here is going to be H is going to be 10 centimeters to 6 centimeters, right? And so our goal here is we want to have in terms of H. So that means that in this volume formula up here that we want to replace R with whatever it equals in terms of H. So if I did H over R and I move the R over, that's still going to be, I'm not replacing H, I'm replacing R. So I'm going to switch these. So I'm going to switch these. And so it's going to be R over H is equal to 6 centimeters over 10 centimeters. And so when I do this, now I could just move this over, and I know that R is going to equal 6H over 10, which is going to be 3H over 5. So that's what R is, because I want R to replace it. So I want R equals, and that's the easiest way to do it. So in the volume here, in terms of H, is going to be V is equal to pi over 3. And now we're going to put in the R squared, which is 3H 5 squared times H. And so when you solve for it, you're going to get V is equal to 9 pi and then over 75 H cubed. And so that actually reduces to 3 pi over 25 H cubed. Okay, so once you have that, and that is your answer for that problem. Find the volume of the water in terms of H. So here in terms of H, they're just telling you that they want you to have V of H. So we have found the formula there. So then we say the next one, how fast is the water level falling when the depth is going to be 8 centimeters? So now we want to find out how fast, so that's the rate. So we are looking for the water level is going to be dH dt, and we know that H is going to be 8. So we want to know when H is 8. We have a formula here, the V of V is equal to 3 pi over 25 H cubed. And since we're looking for the derivative, we want to fill that in. We also know from the very beginning that dV dt is going to be 1.5 centimeter cubed per second. So we know that's the information that's given. And so we know that this here, when we take the derivative, we're going to get dV dt. 3 pi over 25 is the coefficient, so that stays the same. So we multiply this times 3. This is the chain rule, and this is going to be squared, so that's the outside, and we still need to take the derivative of the inside, which is dH dt. And then we fill in the information here. And so we end up with 1.5 centimeters cubed per second. And here we end up, it's going to be over 1. And so we get to, we know that the H is going to be 8. And so here we end up with 9 pi over 25 times 8 squared. That's still over 1. And then the dH dt we do not know. So you fill that in, and then you simplify it, and you get 1.5 centimeters cubed per second. equals to 576 pi over 25 centimeters squared dH dt. And then because this is a coefficient multiplied to dH dt, we are going to multiply by its reciprocal since they're both fractions over second times 25 over 576 pi centimeters squared is equal to dH dt. And then notice how this cancels and we're just left with 1 centimeter actually. So it would be centimeters cubed. So that changes and we just have that. And so my answer there, once you're done calculating, is that it's 0.02 centimeters per second is my DH. So the height is increasing at 0.02 centimeters per second. So that's what you would have to write as your sentence. The water level is falling when, how fast is the water level falling when the depth is 8 centimeters? So one of the things here is that it is actually, it's saying that it's falling, and so therefore that the volume is decreasing. So this should be negative. And so when we go through the whole entire thing, this should be negative as well, negative, negative. So the answer here is negative, because when you go back and read, you should always at the end go back and read your answer, and it says falling, so you know that your answer should be negative. And so this here, it's falling at 0.8 centimeters per second because it's the water, it's full, and then it's decreasing. So that's your answer there. It should be a negative. Okay, very good. Don't forget to write your sentence.